inequalities. One's called a system of inequalities, and one's just doing an inequality. So basically, it's the same idea. Okay, so let's start with an equation here. Let's go y is less than or equal to negative 3x plus 5. Okay, we're going to start off with that. How do we graph this one compared to just a regular line? Do we treat it any different? The only difference is, in the end, there's going to be some shading. Because once again, an inequality has an infinite amount of solutions, correct? There's tons of things that would work here that would make this work, okay? So, we're going to graph it just like normal. So where do we start out at? 5, thank you. So I'm going to start out at 5. Okay, starting out at 5. With our slope being negative 3, that means we're going to go down 3 over 1, correct? Okay, so down 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. Or I could go up 3. 1, 2, 3 over that. And there it is. So, with that being said, there's some 4 placements on that line. Once again, we're kind of looking for 3 at minimum, correct?
Good morning, Westlake. Teachers.
Important. Fun stuff. Look at that graph. Okay. Any questions there? Let's see your practice. Let's go ahead and do 64 today off of your packet. 64. Okay, 64. Says, for a fundraiser, the math club agrees to sell candy bars and candles. Okay, 2 different things. Club's profit will be 50 cents for each candy bar and $2 for every candle. The club needs to earn at least $1,000 to pay for the upcoming field trip. Write a linear inequality that describes the combination of candy bars and candles. All right? Candy bars and candles. Let's first write our equation. What do we need to earn at least? Could we earn 1,000 and be okay? So therefore, is it equal to or not? So could we earn more than 1,000? But if we're less than 1,000, that's where we're struggling, right? So we need 1,000 needs to be like such. We want more than that, don't we? Everybody there with me? Okay? We want more than 1,000. So therefore, how much do I get for every candy bar? 50 cents. And I'm going to call my candy bar X. And I usually put that over here. X equals candy bar. Just so I can remember what's happening. Okay? How much do I get for a candle? $2. So $2 for every candle. Right? This is representing what this is saying. It's saying I get 50 cents for every candy bar, $2 for every candle, and we want that money to be greater than or equal to 1,000. Everybody there with me? Sometimes people struggle writing these equations. Do you agree? So what I do a lot of times is I just pick some random numbers. Okay? So let's, for example, I pick 3 candy bars and 10 candles. How much money would I have earned? Not that much, but still, how much money did I earn? $21.50. Jacob? Hippo, I got the hippo right. Okay. So Jacob, how did you come up with the $21.50? Because in general, guys, that's when we write our equation. Can you tell me your thought process, please? But what if you didn't have this? Yeah, what if we didn't have this? So I'd be getting $1.50 here, huh? Okay, how did we do that? Well, we took 50 cents times it by 3. What is 3 representing? My variable. So you see how just doing that thought process tells you what you're doing for your equation? Okay, and then what did you do for the 20 bucks? You said, oh, well, each of these candles is $2 for every candle, isn't it? So when I add those together, I get my $21.50, right? So basically him just saying, oh, this is how much money it is, he just basically wrote the equation that we needed anyway, right? Sometimes just plot, if you're struggling, pick a point, write it up, and just think about your thought process, and then take out the point that you used and put variables instead. With me on that, I'm trying to go there. Notice he said 50 cents times 3, that's how he got his $1.50. $2 times 10 got him his 20 bucks, and then he added those together. There's your equation. Okay? Anyway, with that being said, let's go ahead. I'm going to just skip this and go over because there's lots of stuff on the other side. So we had 0.5x plus 2y greater than or equal to 1,000. Okay? Now our graph over here is only going 10 by 10, but we can say different ideas about it. We can always rescale it, can't I? Okay. All right. So let's go first off and talk about. Once again in this state, I like to graph via my intercept. So what would be my x-intercept? How many candy bars would I have to sell if I just selling candy bars to at least make $1,000 bucks? 2,000, because 2,000 times 50 cents equals 1,000, right? So my x-intercept would be 2,000. And that makes sense because I plug 0 in for the y, right? 1,000 divided by a half would be 2,000 candy bars, correct? If I was just selling candles, how many candles would I need? In this case, that's our y-intercept. 500, and that's because, once again, y-intercept, I'm plugging 0 candy bars, so 2 times 500 would get us to our 1,000, right? All right, let's do these little increments. I know it's down here, but we can change our increments by ourselves, right? We're going to call this right here 2,000. This is going to be 1,000. So each of these increments is going to be 200. Is everybody with me on that? Each of these increments will do the same idea. This will be 1,000. This will be 2,000. Okay? Just so I can keep good increments for the whole thing. Good? All right, so plot the points again. 2,000 comma 0 would be right here. 0, 500. Well, if he's 1,000, I go about halfway. Right there. Now, what are some other restrictions that are on there even though they're not on there? They're not up on the board yet. Am I going to have, let's draw this line really quick. Okay. What's really my solution though? Is all this side over here my solution, or technically over here? Okay, let me hear you just take a point. Let's pick 0, 0 and see if it works. And then we can talk about what I'm going for. If I did 0, 0, I get is 0 greater than 1,000. True or false statement? False, so I would shade the other side, correct? But ladies and gentlemen, why am I really only shading that area? Notice I'm not going down here, and I'm not going over here. Can I explain why can I? Well, not negative money, but negative, because what's the x-axis represent? Candy bars. Can I have negative candy bars? Can I have negative candles? No. So that's why this is my solution. Even though my graph's continuing on, I'm not going all the way down there because that's below the x-axis. Doesn't make sense to sell negative candy bars or negative candles, does it? So we actually had a couple other equations on there that wasn't written with us, but we also know that x has to be greater or equal to 0 and y has to be greater or equal to 0. Those are kind of some implied restrictions as well, right? Everybody get me on that? Now, let's make sure I answered everything. I think we had to graph it first. Is that correct on that 64? Yep. So it says, write a linear equality describes the combination of candy bars and candles, which we did. Now, I've never asked this to graph, but graphing is still a good idea just to practice it. So part B, will selling 500 candy bars and 350 candles be enough for the trip? How do I know? Plug it in, okay? So I'm going to scroll down here. What was our candy bar? 350 or 500? 500, 350, is that what it was? I was? Okay. So, once again, I'm just plugging it in as you said, right? So I have 0.50 of 500 plus 2 times 350. Is that greater than or equal to 1,000? This comes out to be 250. This comes out to be 700. Was it a solution? Not a solution, was it? Let's check our graph really quick just to see if that happened. So 500 candy bars, 350. 500 candy bars is right here. 350. So it's kind of close, but my graph's not as accurate as it could be, right? Once again, I'm doing this by hand, so kind of sometimes it's hard to see those. But it's just if you never know, just pick a point, plug it in, see if it works. Okay, part C says what? $400 candles. Thank you. Okay, so let's try it again. So I got 50 cents for every 600 candy bars plus $2 for every 400 candles. Is that greater than or equal to 1,000? So I get 300 bucks out of that, plus 800 out of that. That's 1,100. Is that greater than or equal to 1,000? And we're good to go, huh? Any questions on that? 1,100? That one? Sorry. I swear I write some stuff and it doesn't always get up there. Okay, how to 3.4? Anything really too hard on that one? We're okay with that, right? Okay, all right. Any questions there? Okay, 4-6. When we jump into 4-6, it is a system of inequalities. So what does a system mean? The system of inequality. So that means more than one inequality situation. Correct? Okay. So that's what we're going to roll with. Even though they're in 2 different chapters, that's why we're putting them together, just so that we can work together on it. Okay, here we go. $4-6. Okay. Now I could go ahead, I don't know if you guys like it like this one. When I'm in standard form, it's not as pretty as if I was probably in y equals mx plus b or slope-intercept, correct? Because what's my x-intercept of this first equation? It'd be 5/4. Not as accurate to graph. Would you guys agree with that? So if I was going to solve for it, y is all by himself already. Just add him over to the other side, correct? Now remember, what happens if I divide or multiply by negative, though? Switch the sign. By adding him over, am I dividing or anything by a negative? Nope, so I'm still okay. So this is still equivalent to y is less than 4x minus 5. Would you guys agree with me on that? Yeah, I just added the 4x over the other side, Greg. Any questions there? Okay, so I'm going to plot my points. So I start out at -5, and rise 4, run 1, rise 4, run 1, rise 4, or go down 4. Should it be dotted or should it be solid? Dotted, right? Okay, there's that one. I'm going to hurry and shade it with my blue here. What side should that be on? Let's pick the point 0, 0. Is 0, 0 allowed to pick? What if it did go through 0, 0? What would I have to do to pick a point? Just pick any other random point. Does that make sense? Not on the line. I pick 0, 0 a lot. So here we go. Is 0 less than -5? True or false? It's a false statement, isn't it? So where am I going to shade? The side of 0, 0 or the opposite side? Does everybody understand the opposite side? Okay, so here we go. We're going to shade, do it in this lovely purple. Awesome. There it is. That's my first thing. Was that any different than what we did previously? Nothing different, right? But now I have to go ahead and work on this guy. But with this guy, okay, if you'll notice, he's in standard form and it works nicely with my intercepts. Because what's my x-intercept? 2x equals 10, so x would equal 5, right? So x equals 5 is right here. Okay, who's my y-intercept? -2. Does everybody see that? I can just do it quickly. If I need to show you the math, I can. But basically, once again, remember x-intercept one's y0, so I basically just cover him up and solve, right? The y-intercept is when x is 0, so I basically just cover him up and say it's -5y equals 10. That's what I'm doing. So that's -2. Dotted or solid line. Dotted again. Okay. Now let's go ahead and shade him. What's a good point to pick in for him as well? Did it go through 0, 0? It did not. So let's pick 0, 0. 2 times 0 is 0. 5 times 0 is 0. Is 0 less than 10? That is a true statement. So which way do I shade? The side of the point, right? So that would be up here. So what's my solution? I'm going to do it in this black here. It's what's double, right? So I'm going to do the line so it shows us our boundary, okay? So this boundary is here. It's all this in here. This would be my solution, right? Where they're shaded. I know that's really ugly, but that's the solution, where they're both working. Because what that means is both of those points, it's kind of like an and statement, right? That it has to work in both of them. Does that make sense? So notice, once again, the area in the black up here, I can pick any point in this area, and it should work in both equations. That's what a system is. Okay? You also might want to hear the voice, the word, is this bounded or unbounded? And what do you guys think bounded means? Basically, your area is trapped. That's what I think of it. Okay? Meaning it's within a specific area. It's not just growing on to infinity. Okay? So with our chart up here, would it be bounded or unbounded? Unbounded, because I can just notice it's still going on to infinity, right? All this region. For example, of a bounded idea, you might have something like this. Where all of those work right here. You know, it's within boundaries. That would be a bounded solution. Make sense? Questions on that? We do that? Okay. We're going to do a couple others, but just in general, I just want to make sure we were there on top of it. Okay, I'm going to erase this though really quick because I'm running out of my little things I've already made. Okay, here we go. So, let's go ahead and do another one. Okay, I'm going to work on the top one first, which I'm going to do in the blue. Okay, 2x plus y is greater than or equal to 2. So I'm going to just, I think I could graph that using my intercepts, my x-intercept being 1. Does everybody see that? My y-intercept being 2. Very good. X-intercept 1, y-intercept 2. X-intercept 1, y-intercept 2. So basically it's going down 2 over 1. So I can follow that if I wanted to be a little bit better. Okay, should that be a dotted or solid line? Top one? Thank you. Abigail, right? Okay. This one I'm going to do in red. Starting out at my y-intercept at -2. Going down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. Okay. Should that be dotted or solid for the bottom one? Be a dotted line, correct? Okay. Okay. Let's go ahead and shade the blue one first. Okay, so that's the top. Once again, is it going through 0, 0? Nope, so I'm going to go ahead and use it. Is 0 plus 0 greater than or equal to 2? That is a false statement. Here is 0, 0, so I will be shading the opposite side. So that's that area, huh? Right? Notice this one's not also going through 0, 0, so I'm going to pick it. Is 0 less than -2? No. So that's this side. Now my question to you, even though it's not showing me on here, will these graphs ever intersect? Why not, Thane? They are parallel. How did you know they're parallel? Besides just looking at them. Could you tell me the reasoning? That is true. They have the same slope, if you didn't notice. They both have the slope of -2. Okay? So therefore, because they have the same slope, they're starting at different y-intercepts, they'll never hit each other, will they? And notice, the region that they are shaded never shares. Correct? Because it never shares, remember, these are like what kind of statements? Ands or ors? They're like and statements, so I need them where they both share, don't they? And notice that doesn't happen, so what is this? This is a no solution. Okay, because they don't share anything, it's not there. Now, I want you to be aware, unless they're parallel, lines always intersect. It might not be the intersection where you can see it though, right? Okay, it might not be within that specific window that you're drawing, but they would intersect. So that's why it's always important to extend your lines as far as possible. Okay? Any questions there? All right, we're going to go ahead and do a story problem now. Okay? All right, I want to find a better one. What do you guys got here? They're better. Let's do 103. Let's do 103 together. So 103. (103) says this. Okay? Anna has a maximum of $4,000 to invest. One investment pays 6%, the other investment pays 8%. Anna's financial advisor recommends that she invest at least $500 in the 6% and at least $2,500 in the 8%. Anna wants to earn at least $275 annually a year. Okay? So, let X denote the amount invested at 6% and Y about the 8% and write a system of equations. All right. So, let's talk about how much money she gets to have. What kind of money does she have? $4,000, right? And what do we need to put into $4,000? Can we invest less than $4,000? Can we invest more than $4,000? No, so it's going to be a less than or equal to $4,000. Do you guys agree with that? First off, that's always what I like to start at. Now, what two types of things have to add to be that $4,000? We have two different kinds of investments, didn't we? Which was X, which represented 6%, and Y, which represented 8%. So if I add the 6% plus the 8% together, we know it has to be less than or equal to 4,000. Agreed? Okay. So there's that first one. What else did it say here, though? It said that Anna's financial investor asked her to have at least, in her 6%, at least $500. Did she have more than $500? Did she have less than $500? Nope. So X has to be greater than or equal to 500. Yes? Everybody with me there? Okay. What about that 8%? What did he talk about? That he wanted at least what? 2,500. So our Y has to be greater or equal to 2,500. Okay? Is everybody there with me? What are two other things that are kind of not written in the story, but we need to know as well? We have negative money. So X has to be what? Greater than or equal to 0, correct? What else do we need to know? Y also has to be greater or equal to 0. correct? Okay. And then this one's a little bit crazy. It gets a little bit nerve-wracking because we actually have one more as well. Because it also says she wants to earn $275 for her investment. How do you get an investment? Like, let's say I put $1,000 into that 6% account. How much did I just earn? How do I do that? It's 0.06 times 1,000, right? I get $60 out of that. So remember, that kind of helps us write this other equation that I'm using, which it says that she wants to at least earn $275, and how I get that is by doing 6% of X and 8% of Y. So those are all your inequalities that are necessary for this problem. That's a lot of system right there, isn't it? Okay, with that being said, though, we could go ahead and that kind of helps us. Let's see if I guess I can move him over there. But basically, that means, though, our answer's in that quadrant. Do you guys agree? Because that's this one and this one. Right? Okay? All right, how do you guys want to do our increments here? Can somebody do me really quick this so I know here? Let's find our x-intercept of this equation. You have your calculator out for me, Landon? You go 275 divided by 0.062. $275 divided by 0.06. 4,583 would be my y, my x-intercept there. How about doing 275 divided by 0.06? We'll get to those in just a second.
3,437.
All right. So, ladies and gentlemen, these are my x and y intercepts. So basically, if I have 4,000, it should be enough. Does that make sense if I go a little bit past it? So let's do every tick mark is representing 500. Are you guys okay with that? Every tick mark representing 500? So I might just want to dictate that here. Every mark is 500. Okay, just so we know our scale. Now, if you're doing your own scale, you could just mark them by 500 on your own, right? But I'm using this one so we have a little bit nicer, okay? So if that's the case, let's go every tick marks 500. So we already have that this is these two intercepts, okay? So that's roughly in between 9 tick marks, closer to 9 tick marks, but 10. So roughly right there. That's a little bit less than 7 tick marks because 3,500 would be 7 tick marks, correct? So it's a little bit below there. All line again. Okay, there's our first one. So that's graphed in red. Let's graph this guy in purple here. What's our x and y intercepts? They're the same. They're both at where? 4,000, right? Does that make sense to you? Tell me your name again. Because if I plug 0 in here, I need 4,000 here and vice versa. Okay, so that's at 8 tick marks. Okay. The bigger we draw this, the better it would have been, though, right? To be honest. But with this being said, okay, what else? We've got this guy, these guys, we got that guy. Let's do this guy. X has to be greater than 500. That's, by the way, is this direction. That green kind of sucks, doesn't it? Then we need to be greater than 2,500. This line. We're looking above it as well. Okay. So now we need to figure out where they actually graph. Okay, where does all these guys work? So notice, for the purple one, it has to be less than the purple one. Because 0, 0 would work in that equation, would it not? So sometimes before I shade when it gets all this way, I just say, okay, I will be shading that side of this graph. Does everybody see what I'm doing there? Before I truly shade, I'm just pointing on the side that it would shade. Yes, no? You guys are one quietish group today. And I know some of you guys talk a lot because I've heard you. Did you get initiated? Are you good? You in? Not, what else you got to do? Steal some, like, chicken from some yard or something? I bet that'd be fun. Anyway, don't do that. Okay. Yes, thank you. Okay, if I plug 0, 0 into this, does that work? Is 0 plus 0 greater than 275? No, so I'm on this side of the red. So notice I'm on this side of the red, that side of the purple. Okay, so I'm on this side of the red, but that side of the purple, this side of the green, and that side. So you guys see it? This region right. That's my shaded region. Okay? Because that's where it works for every single one of them. Right? Has to be above that. Has to be above 2,500, so hence why I'm right there. Has to be more than 500, that's why I'm over on this side. Has to be less than the purple one, which is the 4,000. But it has to be greater than this guy, which is above the red one, hence that mark. Now, you also have, I don't really think we need to get into this so much, but you have these points, okay? You have these barriers. You see how we have this intersection point, that intersection point, that intersection point, and that intersection point? Okay, we should be able to find those. Okay, so if you notice, basically that these two intersection points is when x is how much? 500, right? Because that's what that line is representing. So I put 1 into this equation at 500, I solve for y. I plug 1 into here, put 500 in, solve for y. So this top one is 500, comma, 3,500. Does that make sense how I found that? Okay. Will you do 500 times 0.6 for me? Yeah, just 0.6. So I have 300 plus 0.08y has to be equal to 275. I didn't have that one. I don't know what I did wrong there, but something's wrong there. Anybody see what I'm doing wrong on that one by putting 500 in? 500 times that should be 300 or should be 30. You do 500 times 0.06? Should be 30 or 300?
You told me.
Oh, apologize. Okay, that's what's making me nervous. I'm like, something's wrong. Okay. Phew. It's like, all right, 30. That makes me feel better. All right. So here we go. We can hurry and solve that now. So I have 0.08y equals 245. We now divide 245 by 0.0. So this point right here That's 500, 3062.5. So what we're doing is we're finding the boundaries. Does that make sense? And that's where these intersection points are. Okay, I'm not going to find the other ones, but notice what does this orange line dictate? When y is how much? 2,500, right? So I plug 2,500 into y, and this point right here would be 1,500, 2,500. Okay, and then the last one, so that would be this guy. Done. It's on the wrong line. Okay, and then this one, I'm going to use your machine again with me. Plugging 2,500 and I have 0.06 x plus 0.08 times 2,500 equals 275. 0.08 times 2,500. 200? Straight up? Oh, that's right. 0.06 x plus 200 equals 275. 0.06 x equals 75. 75 divided by 26. 1,250? Yep. There we go. So now we have all the barriers that it's needed. Okay. Is that a bounded or unbounded situation? It's a bounded situation, right? All right. You guys need me to do more? Basically, it's the same stuff, right? It's just multiples, but then the hardest part is just finding where they intersect. What if these guys intersected? How would I solve these guys? One of those guys intersected. I'd solve for y with one of these equations, and I'd plug it into here, and I'd solve for it. You guys remember doing those systems, those basic systems? That's where that would come in. Okay, with that being the case, you're on this page right here. I believe that's all there is. That's one page. Okay, yep. So, on 4-6, I'm going to have you guys do all of them. But on the 3-4, you guys can just do the odd. Just because there's more practice in there, okay? I'd rather have you practice a little bit more on those bottom ones, get you a little bit more access to it. So, on, once again, 3-4, you're going to be just doing the odd. But on 4-6, you can do all of them. Obviously, you did the story problems, you guys can just do the other story. There you go. Any questions? So you guys still have about 15 minutes and we'll work on that. That'd be awesome.